Let us now look at the differences between interference and diffraction. Even though these two phenomena seems to be different, but they're actually interconnected. Before looking at the differences, let us look at a quote from a famous scientist called as Richard. Richard Feynman was a very famous and important scientist who made important contributions in physics, particularly in quantum dynamics from 1960s onwards. Now there's one of his quote given here. He says that no one has ever been able to define the difference between interference and diffraction satisfactorily. Which means he says that there's not a single person who's able to differentiate clearly between what is interference and what is diffraction. And this happens, it's interconnected. If they're two different processes, then it is very easy to differentiate them. But it's interconnected, then we can't tell as to what is interference and what is diffraction, because sometimes they're interchangeable. He also says that when there are only a few sources, say two, we call it interference. So just to differentiate them, is saying that if there are two sources, then the phenomenon is called as interference, as seen in Young's double slit experiment. But with a large number of sources, the process can be called as diffraction. Now the question which comes to mind is, in case of diffraction, what we saw was only a single slit and a single source. That is, we had light coming from faraway object and we had only one opening. Here, there are many sources, because what we see is only one source. But if we look at the study of diffraction at single slit, then we assume that we can divide the region between the two slits into n number of wavefronts, and each wavefront arriving here would emit secondary wavelets. These secondary wavelets would superimpose, giving rise to diffraction on the screen. So in that sense, we can assume that each wavefront acts like a. Again, to summarize it, there is no clear boundary, because we can't tell this is interference or diffraction always, because many times they are interchangeable. Now let us look at the differences one by one. The first difference is based on occurrence or based on how they are created. In case of diffraction, it occurs because of secondary wavefront. It's not wavelet, it's wavefront. Secondary wavefronts superposition. Because we saw that if we have a slit, then we can divide the slit into regions containing n number of wavefronts, and each of this would emit secondary wavefronts, which would superimpose, which would give us diffraction. That is what is diffraction. While in case of interference, we can say it occurs due to light waves superposition, that is from two sources. If you recall Young's double slit experiment, then there was a screen and there were two slits. Slits means narrow opening, and we had only one source. So even here we had only one source. Example, think like a bulb. But from this side, if we see from the screen point of view, the two slits S1 and S2 behave independently like two different sources, even though the light through S1 and S2 is coming from a single source only. But from this point, we can see it behaves like two sources. Hence, the waves from here and waves from here would superimpose, giving rise to interference. We can define saying that interference, there is superposition of two waves. The next difference is about the width of fringes or bands. In case of diffraction, we saw that the bands are of unequal width. The central band has maximum width. While we go away from that, the width would decrease. While in case of interference, the bands would have same. The next difference is based on intensity of the fringes or bands. In case of diffraction, as we saw earlier, the central maximum has the highest intensity, and when we go away from it, the intensity will decrease. But in case of interference, all the bands will have same intensity. That is, all the bright bands will have same intensity. The next difference is based on obstacle or slit. In case of diffraction, we need an obstacle. That is, there is a requirement for an obstacle. That is because by very definition of diffraction, we saw that diffraction basically means that bending of light rays around obstacles. So if you have an obstacle like this, light ray would bend around the obstacle and light rays would enter into the geometrical shadow region. The obstacle is a must for diffraction, while in case of interference, there is no need for obstacle. Rather, what we need is two or more waves. Next difference is based on the fringe spacing or the band spacing. In case of diffraction, there is no uniformity in its width. That is because central maximum will have the highest width, or we can look at in terms of the intensity graph also, graph of intensity versus path difference. The central maximum had the highest intensity, then intensity kept on decreasing. This is what we got in case of diffraction. While in case of interference, we saw that all the bands, all the bright bands, will have same intensity. This is for interference. Last difference is the contrast between maxima and minima. Contrast means how much clearly we are able to differentiate between bright and then dark bands. The contrast between the bands is dark and bright band in case of diffraction is poor, and the contrast is good in case of interference. Understand this? Let's look at the intensity graph seen here. So if you look at central maximum, we can tell the difference between bright and dark clearly here. This is bright, this is dark. But if you look at the other maxima or minima, look at this one for example, it is getting more darker. So the contrast, the contrast, that is the difference between bright and dark is decreasing. If we go away from the central maximum, that is, if the order of the maxima increases, then its brightness will decrease. In such cases, the contrast becomes even more poor. So, in case of interference, the contrast between bright and dark is good. That is, the contrast between maxima and minima is good, but it is not so good in case of diffraction, or it is poor. These are the basic differences. For the sake of exam point of view, to understand what is the differences between interference and diffraction, but keep in mind that we clearly can't tell as to what is interference or what is diffraction. It's only based on the usage.